So, today we get to do what's called polynomial long division. I know how you feel about long division. So here's your review problem. We're supposed to find 87,456 divided by 23. So I'm just going to go back over the 4th and 5th grade math algorithm that you used. The divisor is 23, it goes outside. The dividend is 87,456. And the goal here is to figure out how many times, what do you have to multiply 23 by to get close to 87? And it's 3. 3 times 23 is 69. Now, in 4th and 5th grade, you would have subtracted that line. 87 minus 69 is what? It's 18. That's right. Good job. Now, if you got anything bigger than 23, you made a mistake. You drop down to 4. How many times will 23 enter 184? 8 times. 8 times 20 is 160. 8 times 3 is 24. And it's actually a perfect match. So it's 184. We're going to do some subtraction. Double check that real quick. I'm pretty confident in it. We get a 0. So we're actually going to have to bring down 2 numbers this time because 23 won't enter 5, but it'll enter 56 2 times. 2 times 23 is 46. We do the subtraction, and we have a 10 remainder. So we have 382. And, you know, in middle school and in elementary, they didn't quite teach this right. They would always have you write this, R10. That's not right. It's 382 plus 10 pieces of 23. That's what the number really is. I swear that's what it is. You know, like, let me prove that to you, because you're probably like, I don't know why he's talking like this. This isn't what my 5th grade math teacher taught me. There's a reason they taught you 5th grade math, bro. And there's a reason I teach the high school level. They didn't know any better. That's not always true, but it's usually true. So, I always had a problem with how we said that. I remember having an argument with the teacher about that when I was a kid. So, let's take our 87,456, and let's divide it by 23. And we get this funky looking decimal. Oh, you know, I did forget something here. Speaking of me running my mouth. I don't know why I did that, but I'm glad I checked. Since we couldn't enter 56, we had to have since we couldn't enter 5, we had to put a 0 there. Oops. All right, so then we got the 2. And then we got the plus 10 pieces of 8. Plus 10 pieces of 23. I'm glad I checked that. I really am. Anyways, I got this funky looking decimal. So let's compare that to what I got, 3802 plus 10 pieces of 23. And they should be the same decimal. And they are. So that's why we write it like this. Anywho, we got some prerequisite skills here. You are told that x plus 3 is a factor. What is f of 3? So remember, if this is a factor, we would use zero product property, right? Right? And this has a typo. That should be a negative. I need to fix that. That tells me x is negative 3. But f of negative 3 would be a 0. A polynomial has roots. Things that we call roots, we also call them zeros and x-intercepts. At negative 4, 0, 3, 0, and negative 12, 0, what is a polynomial in factored form? So this polynomial, we'll just call her f of x. We're going to change signs. It would be x plus 4, x minus 3, and x plus 12. If f of 3 is a 0, f of 12 is 3, f of 0 is a 0, f of 9 is a 3, f of negative 2 is a 0, and a is a negative 4, was a polynomial in factored form. So every form starts with a. So we're going to put a negative 4. That's just how it works. I've talked about so many forms with you, and every single one of them starts with the first letter of the alphabet. Now, we only care about the zeros. This one says x is 3. Shift left x minus 3 is your factor. Or just change the blasted sign. This one right here would be x equals 0. Shift it left, it would be kind of weird to write a factor as x minus 0. It's just an x. That's all it is. Then we have this one, and at this point in time, we're just going to change the sign and be done with it. That's the polynomial in factored form. Now, a mathematician would put the x before the x minus 3 and the x plus 2. They would. That's just what they do, because it just looks better. All right. Moving on to remainder theorem. Give me just a minute and I'll be right back. Let's see what kind of crazy notes I have written down here for remainder theorem. Given some function f of x, if f of a is a 0, then x equals a is a 0, or an x-intercept, or a root of the function. If x equals a is a 0, then x minus a is a factor. So if f of 3 is a 0, then x equals 3 is a 0. The x-intercept is at 3, 0, and the factor is simply x minus 3. And that's remainder theorem, okay? It is. Moving forward, the actual skills of today is polynomial long division. So we're supposed to divide x cubed plus 7x squared minus 25x minus 75 by x plus 5. So we're going to put our dividend inside. And we're dividing by x plus 5. That's going to stay outside. The question here when you start these off is, what do I multiply x by to become x cubed? And I hope you're thinking x squared. Notice how I line things up, x squareds above x squareds. You don't have to do it, but it helps. X squared times x is x cubed. X squared times 5 is plus 5x squared. And when I went over long division on the first slide here, we subtracted that line. And you should always wrap before you subtract, or you're going to make mistakes. Milbrath has a list of commandments on the wall. I don't know if you've noticed them or not, but 2 or more things you should always wrap. But what do I know? Anyways, we got a 7x. These guys cancel. 7x squared minus 5x squared is 2x squared. Kids' issues with long division is not the long division algorithm. It's the fact that you can't add or subtract. It's always that. And just like in regular long division with numbers, generally speaking, you're going to bring some things down. New goal, turn x into 2x squared. What do you multiply by? Hopefully you're thinking 2x. And then you're going to invoke the distributive property. 2x times x is 2x squared. 2x times 5 is plus 10x. Wrap before you subtract. If you don't wrap, you're going to make mistakes. All right, we have a negative 25x, and we're taking away 10x from that. That's going to be negative 35x. Let me shrink this up since I ran out of room. And we're going to have to bring down that 75 as well. Now, how do you turn an x into a negative 35x? Well, you use a negative 35. I swore I changed color to red there. Negative 35 times x is negative 35x. I need that negative 75 there. Negative 35 times 5 is not going to be negative 75. Negative 35 times 5 is negative 175. Now, if we wrap before we subtract, we're going to get a positive 100. And this is the remainder. Okay? So plus 100 pieces of x plus 5. Was x plus 5 a factor of f of x? No. The remainder was not 0. We did not enter what we call evenly into the original polynomial. What was f of negative 5? It was 100. It is 100. And this is actually a good way to check your polynomial long division work. Your remainder should match what you get when you plug the number in. That's actually worth typing out. So I'm going to use a storage feature here because I hadn't done it in so long. I'm going to take a negative 5, store it to x. Do you understand why I was talking about negative 5? Because think about this potentially being a 0. X is negative 5. Okay? That's why we're talking about that being negative 5. Anywho, let's take that storage feature, go push some buttons in a calculator. For some reason, I had really thought that I did this lesson the other day, but I had not. I was not expecting to come in this morning and be recording this one. And I got 100. That tells me that my long division was correct. It's a pretty good thing to do. And I'm going to write that down. A good way to check your long division work is to see if f of a is equal to the remainder. F of a is kind of a funny thing to do here, but to see if when I plug a number in, I get the remainder back. And if I do, I probably did everything right. All right. We're supposed to find here f of x divided by g of x. Hopefully you understand that that means take f and divide it by g. And let's see what happens on this bad boy right here. We have 3x to the fourth, we have a negative 5x cubed, and there are no x squareds, and there are no x's, or it's called placeholders, and then take away 6. We're dividing by the divisor, x squared minus 3x plus 5. And our first goal is about those two pieces. What do I multiply x squared by to become 3x to the fourth? And hopefully you're thinking the correct answer, which is 3x squared. 3x squared times x squared is 3x to the fourth. 3x squared times a negative 3x is minus 9x cubed. 3x squared times 5 is plus 15x squared. And again, you wrap before you subtract. There will be no x to the fourth left. Negative 5 take away a negative 9 is a positive 4x cubed. 0 take away 15 is minus 15x squared. New move. I want to turn x squared into 4x cubed. And hopefully you're thinking I'm going to use a 4x. And then I'm going to distribute 4x cubed minus 12x squared plus 20x. Unless I forget something, I do this a lot. I got to bring that down as a placeholder. And again, I wrap before I subtract. Now, a negative 15x squared minus a negative 12x squared is a negative 3x squared. And 0 minus 10 is negative 10x. And let's just go ahead and... I don't need anything else. Oh, yeah, I do need this negative 6. It's going to be required. I can turn an x squared into a negative 3x squared by using a negative 3. So let's see here. We have a negative 3x squared. We have a positive 9x. And we have a negative 15. And then I wrap before I subtract. That's why these guys cancel. Negative 10 minus 9 is negative 19x. And negative 6 minus a negative 15 is a positive 9. So here's my quotient plus my remainder, which is negative 19x plus 9, pieces of the original divisor, x squared minus 3x plus 5. Good stuff. Good stuff. Moving forward here. We got 2 left to go. Use the fact that x plus 6 is a factor of f of x equals 2x squared plus 12x squared minus 4x minus 24 to completely factor f of x. Now, it doesn't actually bear it to this problem, but if x plus 6 is a factor, f of what is a 0? The answer is negative 6. Remember, you change signs, kids. It's how it works. It ain't that hard. For some, I guess it is. All right, our dividend, 2x cubed plus 12x squared minus 4x minus 24 goes inside the vinculum. Outside of this thing is x plus 6. Yeah, it's called a vinculum. Weird, huh? What do I multiply x by to become 2x squared? If you're thinking 2x, winner, winner, chicken dinner, 2x times x is 2x squared, 2x times 6 is plus 12x. Let me put that there. Like things need to go with like things. And again, you wrap before you subtract. This guy is just going to fall all the way through. Negative 4x take away 12x is negative 16x. Now let's bring down that negative 24. What do I multiply x by to become? That was a cube. Blast it. Square. Erase. Start over. 2x squared times x is 2x cubed. 2x squared times 6 is going to be 12x squared. Sorry about that. But at least I caught it then. All right, so if I subtract, I'm going to have a 0. And because there's two things here, I probably need to go ahead and bring down these two things. Now, what do I multiply x by to become negative 4x? The correct answer is negative 4. I'll get negative 4x minus 24. And if you'll wrap before you subtract, you'll find that you have a 0. All right, so this is our quotient, and there's a remainder of 0, so it's just that. So the real question is, oh, by the way, let's talk about what we've done. So far, we know x plus 6 times 2x squared minus 4 is equal to f of x, the original polynomial, because we did division. So the real question is does 2x squared minus 4 factor? And it does, believe it or not. We can pull a 2, put it out front. That'll leave us with x squared minus 2. Now, does x squared minus 2 factor? Yes, it does. The easiest way for y'all to discover if x squared minus 2 factors is to write it equal to a 0 and solve. Don't forget to take include the plus or minus symbol. This tells me that x is either positive root 2 or negative root 2. So let's talk about this. If x equals root 2 and we shift left, x minus root 2 is a factor. And vice versa for the other ones. So my complete factorization would be 2 times x plus 6 times x minus a root of 2 times x plus a root of 2. Ta-da! I'm sure you love that. All right, last one. You were told f of 3 is 0. Use that to completely factor that polynomial. This, by the way, says x is 3, so x minus 3 is a factor. That's one of them. Now, anyways, we're going to take our 4th degree polynomial and we're going to divide it by x minus 3. And you'll take a few steps. To make an x to the 4th from an x, you need a x cubed. You're going to get x to the 4th minus 3x cubed. This won't actually be too long on the division because all these that I made are things that actually factored by grouping. Anywho, that's going to give me a 0. So I'm going to bring down 2 more terms. Turn x into 8x, I need a positive 8. That's going to give me 8x minus 24. I have a 0. So here's what I know. I know that right now I factor is x minus 3 times x cubed plus 8. And so now the question is, does x cubed plus 8 factor? You betcha. It does factor. We're going to use the a cubed minus b cubed pattern that we learned about yesterday. It's a minus b times a squared plus ab plus b squared. So when you look at x cubed plus 8, you have an x that is cubed plus a 2 that is cubed. So a is x and b is 2. So let's copy down x minus 3. We're just going to bring it down. I'm going to be x plus 2 because a is x and b is 2. This is a plus 1, sorry, plus minus plus. I don't know why I wrote the minus pattern there. It's plus minus plus. And then I have to square x. I have to take away the product of 3 and x, which is 3x. And I have to square the 3, which is 9. Perfect. Remember that this piece is always imaginary. It actually does factor to some degree. We're just not there yet. This is completely factored over what's called the real number system. And that's it. That's what I got for you. I got one more video to make.